Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In this lesson, I want to continue from our discussion from the last lesson where we learned about function pointers. But this time, I'm going to show you something kind of really neat that you can do with function pointers, and that's pass functions as parameters inside of other functions. And this is something that's known as a higher order function, which D supports the ability to pass in functions as other function parameters. And again, this is how you get higher level behavior and can do some really interesting and powerful things. And it's another reason that using D is useful, like many other languages, when you can pass functions as parameters and create new or compose new behaviors. So anyways, with that said, let's go ahead and take a look at how to do this, and I'll show you a few other useful tidbits as well. All right, so just to review what we did last time, we learned about this function keyword here, which allowed us to create a function pointer, often abbreviated FP, to specific types of functions. So again, this function pointer allows us to point to functions that have void return type and no parameters. This function pointer here, return type of int and two integers as the parameter. And again, as I mentioned, usually I might name it something like this. So we saw an example then where I used this void function pointer, pointed it to a function like hello, which again matches the function signature, meaning the return type and no parameters. And then it could behave by printing out hello. And then I can repoint that function pointer to by here and then call the function, and you'll see the different behavior here. So let's go ahead and just create that here by running our main here. And you can see that first example. And then I repeated this experiment just to show you with different parameters, something that you can do here with add and subtract in this instance. Again, just to show you two different functions here with the different return types and reusing that function pointer. Now let's go ahead and learn about this idea of a higher order function. So let's just go ahead and say that I want to compose some program to do some sort of behavior. And for this particular program, I'm just going to write a void function here, and I'm just going to say a greeting message here, and then we'll do some behavior here. Now, what I'm going to go ahead and do here is take in two function pointers here. So void function and another void function, and I'll just refer to these as 1 and function 2 here. Okay. And let's just go ahead and compile this, make sure that it's working, still working as normal. But again, the difference being that I'm taking in a function as a parameter here, which I'll refer to as 1, and a function here that I'll refer to as 2. Again, 1 and 2 just being function pointers that are passed in by copy here, and then we can call those functions 1 and 2 here. Okay, so let's go ahead and finish off this function. I'll just call 1, and then I'll just call 2 here. Now let's actually make use of this particular program here. So let's comment out the rest of our code since we're not really doing anything super interesting with it. And we'll go ahead and call our greeting. And I need to pass in two functions that are void on each of them. And I know I have the hello function and the by function for that. Okay, now let's go ahead and see if this works. If I go ahead and compile this, well, again, we're going to get errors here because, well, as we remember from last time, this is a function pointer. It stores an address, so we need the address of these functions. And now we can run this. So again, really interesting that I can just call this function here greeting and take in these functions here and have them called. And this again is going to allow us to have some really interesting sort of emergent behavior that we can do with our programs by using things like composition and building more powerful algorithms and data structures, which we'll get to in this series. But you can do the other things that you do with functions that we'll cover. Like for instance, if I don't supply any parameters, I could just give a default here. Let's just go ahead and make this by for the second one. So if I just put in a greeting, and then I just go ahead and put in the address of by, just supplying one parameter here. And let's go ahead and comment this one out. Then again, I can have by and just have a default parameter here. So again, it gives you sort of default behaviors, and you'll often see this sort of thing in, for instance, algorithms libraries. If you're sorting or passing in some sort of sorting key, that there is just, again, a default argument here for the behavior. But again, we're giving our user the ability to change this through the function pointer and make it relatively a much more powerful algorithm. Okay. So with that said, let's go ahead and look at a few more things here. And first and foremost, I think it's interesting to look at the type ID. First, let's just look a regular function here, like let's just go ahead and pass in add, for instance. And oops, I guess add the function here would want to be called here. It'll give me the return type if I actually put something in here. But let's actually put in our function pointer here, void fp, just so you can see the type ID for that. Again, that's what the function pointer looks like. Function, and it's got the asterisk here, which we use for pointer, okay? And we can do this as well for other types of function pointers if we need. Now, the last thing that I want to do here, just knowing what this looks like, I mean, this is the actual type here. So we could replace this if we wanted to, to look something like this. But something that I like to do here, especially if I know I'm going to be passing in lots of functions around, is to not forget that we have some different tools like alias. And I could just call this function pointer 1 and just state that this is a void function here. And I could do another alias function pointer 2 and say this is something that returns an int, a function that takes an int like this here. Okay, and that might be one way to clean up your code a little bit here. Again, by just marking things as an alias here. So again, I'm just going to come into this function signature. And actually, let me copy this and I'll put it in a comment just so you can see what it was before. And you can see the cleaned up version after here. Okay, so we don't want to forget about some of our other programming tools that we have learned throughout this video series, like alias, which can be super useful. Again, if you have a library with lots of complicated and large functions for whatever reason that you're using as function pointers. And then we have the default parameters here as well. And as always, I like to use the type ID if I'm ever unclear about what some actual type looks like so that I can see it there. All right, folks, so if you want to follow this lesson and more, you can feel free to do that on my website here, where you can just follow along and track your progress if you enjoy that, so you don't lose track of where you are in this video series. And with that said, folks, thanks as always for your time and attention. I hope you found this to be a valuable lesson, and I'll look forward to seeing you in the next one.